Hello all, I am Shifaki Salah and I am a student of Government Engineering College, Idukki. Today I am going to take a topic on memory management in GPOS. So let's have a look at memory allocation. For understanding about memory management, we want to know about memory allocation first. When a process is created, the memory manager allocates the memory address or blocks to it by mapping the process address space. So, here we can see that when a process is created, while we are creating a process, the memory manager allocates the memory address. This memory address is also known as block and it is mapped. Threads of a process share the memory space of the process. This threads is helping for sharing the memory space of a process. Then what is meant by memory management? The memory is being managed. After initial allocation, we want to manage the memory. The basics of these are shown here. Memory manager of the operating system has to be secure, robust and well protected. There must be controls such that no memory leaks and stack overflows. So, when there is memory managing, there must be no memory leaks or stack overflow. Then what is mean by memory leak? Let's look at it. Memory leaks means attempts to write in the memory block not allocated to a process or data structure. That is mean by memory leak. And what is mean by stack overflow? Stack overflow means that the stack exceeding the allocated memory block. While we are writing or while we are doing a memory management, when the space is or filled and it gets overflow, that is known as stack overflow. Now let us look at the memory management strategies. There are some of there are many memory management strategies like fixed block allocation, dynamic block allocation, dynamic page allocation, dynamic data memory allocation, multiprocessor allocation and few more. Let's have a detailed look. Here, memory block allocation. What is meant by memory block allocation? Memory address space is divided into blocks with the process having small address spaces getting a lesser number of blocks. So, for a small address space, it naturally gets a less number of blocks, and for process which is big or big address spaces, they get large number of blocks. So, there should be a fixed allocation, fixed block allocation. The next strategy is dynamic block allocation. Let's look at it. Memory address space is divided into blocks with the process having small address spaces getting a lesser number of blocks and process with big address space getting a large number of blocks to start with. And the memory manager later allocates variable size blocks like in unit says 64 or 256 bytes, dynamically allocated from a free unused list of memory block description table at the different communication or computation phases of a process. So next type of strategy is dynamic page allocation. So memory has fixed sized block called pages and the memory manager allocates the pages dynamically with a page descriptor table. So here we need a page descriptor table. So next type of strategy is dynamic data memory allocation. So the manager allocates data dynamically. Here dynamically the data is allocated and different data structures like nodes of lists, queues and stacks. So next type is multiprocessor allocation. The manager adopts an allocation strategy. Either the memory is shared with tight coupling between two or more processors or shared with loose coupling or their multi-segmented allocation. This is known as multiprocessor allocation. Here just a basic idea of some of these strategies. Now let us look at some basics of general purpose operating system or GPOS. Here it is an essential component of any mobile device, server or computer system. So it is an important component of or essential component of mobile devices, server or computer system, and is responsible for running all application in an installation. Some of its examples are Linux, Windows, MacOS. These are some of the GPOSs. And some features are listed here. There should be an interface between users and hardwares, and controlling and allocating of memory, controlling input and output devices, managing file system, facilitating networking, enterprise connectivity, peripheral interrupts, background application, and OS that controls all schedulings. These are some of the features of general purpose operating system. So there is some application also listed. Some of the application are buffer data acquisition, offline analysis, data presentation, etc. And the examples that we already seen here, Linux, Windows, Mac operating system are some of this GPOS. That's also listed here. Then what is mean by memory management in GPOS? So memory management is very important function that a operating system does. What is the reason? Because if we want to execute any program, then the program has to load it in the computer's memory. So computer memory is one of the important resources or common resources to execute one program inside the computer. So here in a general purpose operating system, memory management is quite important, or for an operating system the memory management is very important for maximum allocation or maximum usage of the memory of the system. Okay, there should not be any wastage of memory. That's the quite aim of the memory management. We should not keep we should not keep any program residing in the computer memory which is not now in execution and which could not be executed in near future. And so that's why we should use particular resources to our fullest usage. We should not keep any program residing in the computer which is not now in execution, or we should execute in the near future or before or past or future usages. So we should become very much choosy to select these modules and program segment which will stay in the computer memory, which will be currently in the execution or it will executed in near future and which has been demand for execution, then only that has to be brought in the computer's memory. So we should not jumble with the memory and utilized program code. So to discuss this one, we look at the address binding. Some of the address binding, there is some of the address binding. There is three types of address binding. Let's look at the address binding. What is address binding? So computer memory uses both logical addresses and physical address, that we already know. They use logical and physical address. Address binding allocates a physical memory location to the logical pointer by associating a physical address to a logic address, which is also known as virtual address. So address binding is a part of computer memory management and it is performed by the operating system on behalf of the application that need access to memory. So address binding relates to how the code of a program is stored in memory. This is related to how the code of a program is stored in the memory. There are three types of address binding. Let's have a look. There is three type of binding. What is that? Compile time address binding, load time address binding, and execution time address binding. Now we can look them in detail. Okay, compile time address binding. The first type of address binding is compile time address binding. So this allocates a space in memory to the machine code of a computer when the program is compiled to an executable binary file. The address binding allocates a logical address to the starting point of segment in memory where the object code is stored. The memory allocation is long term and can be altered only by recompiling the program. So, during the compilation, the absolute address get embedded in the executable code. That means the program knows from which address it is supposed to get loaded or from where it is supposed to get executed. So that's why this we have one advantage and one disadvantage for this compile time address binding. What is that advantage? It will require a minimum setup time, and that of disadvantage is a program is going to get loaded getting to a certain memory location which is be occupied by any other program. Then what will happen? Collision will occur. Okay, the current program get override by the previous program. Okay, that's why here some disadvantages is occurring for compile time address binding. Next, we have look at load time address binding. If memory allocation is designated at the time the program is allocated, then no program can ever transfer from one computer to another in its compiled state. This is because the executable code will contain memory allocations that may already be in use by other programs on the new computer. In this instance, the program's logical address are not bound to physical address until the program is invoked and loaded into memory. So, when the program get compiled, then all the addresses will be in the relocated addressing format. So next we can look at executable time address binding. This is usually applies only to variables in programs and is a most common form of binding for scripts which don't get compiled. In this scenario, the program requests memory space for a variable in a program the first time that variable is encountered during the process of instructions in the script. The memory will allocate space to that variable until the program sequence ends or unless a specific instruction within the script releases the memory address bound to a variable. So, when a program has been loaded to the memory, it might be executing also, but during the period of time, if I can move the program from one memory block to another memory block, if it is allowed. Now we can look at some of dynamic loading, dynamic linking and overlay, some of the important features of this memory management. What is meant by dynamic loading? When we are writing a program and the program used to get divided into multiple modules, so when the program is in execution, then the program must be leveled in the computer memory. That's a known fact. So, dynamic loading says that the load the main module first and load other modules when they will be asked. So, let's look at some of the points. Routine is not loaded until it is called. Better memory space utilization. Unused routine is never loaded. Useful when memory amount of code are needed to handle infrequently occurring cases, and no special support from the OS is required and implemented through program design. So, now let us look at the dynamic linking. Let us assume that there is a dynamic module called a differential function and all the modules we are written in the system modules. The module are called different function and the function body is written in subsystem libraries. So when the respective function to be called, if then only the respective library routines come into memory and it gets located in the memory to provide the body of the function. that is known as the dynamic linking. So the libraries are not getting loaded in prior until and unless the modules are executing any function whose body is residing in the corresponding library routine, then only it will get loaded the computer memory, and that is a particular code known as stub. It is an important one. Here we can see there is a detail of a stub which will hold the recorded information that this particular information is having its body in which library routine and where does this library routine in the secondary storage. So at first is loaded which library function that is getting loaded, which will decided along with the execution. So there is some point linking postponed until execution time. Small piece of code stub used to locate the appropriate memory resident library routine, and a stub places itself with the address of routine and executes the routine. Operating system is needed to check if routine is in process memory addresses, and a dynamic linking is particularly useful for libraries. Now, what is meant by overlays? In a general computing sense, overlaying means the process of transferring a block of program code or other data into main memory, replacing what is already stored. Here, overlays Here, overlaying is a programming method that allows programs to be larger than the computer's main memory. So, here we are considering, or when a program is executed, assembler comes to the plane and assembler assembles or compiles program to two passes, pass 1 and pass 2. Let us suppose here we have a pass 1 equal to 60k memory and pass 2 is equal to 75k, and having a symbol table 20k, common routine 35k. Therefore, the total memory space is 190k. Suppose we have 150k memory space. So, there is a question arise, can I compile this form? No, because of lack of memory space. Here the total memory is 190k and we have only 150k. So there is a lack of memory space and we cannot compile this at the same time. All will done by. So this can be replaced by using using this 150k memory space. We can compile this program or store this memory by using an overlay, a remedial measure. Let's look at that. So here is a diagram where we are using this overlay driver. Let us check. Here we are giving a symbol table having 20k, here 20k, and a common routine, here 35k. So here we show this 35k and pass 1 60k and pass 2 75k, and we are using an overlay driver here which is having a 10k memory. So this overlay decides which module exists should simultaneously or which is not. So here this overlay will passes only one pass at a time. So here we can see that here 20 plus 35 plus 10. Here a total of 65k and here we are passing only pass 1, that is 60k. So at a time this pass 1 is only passing, that is 65 plus 60. So here we have a 125k usage, that is not more than the total memory space, that is 150, and when we are passing this only this 75k, then we have a total of 65 plus 75, that's approximately 140k, and this is also not more than 150k. So here 140k is the highest memory. So by using this overlay drivers, we can satisfy or we can passes the data that's or store the memory not more than the maximum storage. That is the main advantage of overlay drivers. Now let's see a multi-step processing of our program, just including a source program which is then compiled or assembled. That is known as compiler time, the time needed for compiling and assembling. And for linkage editor, load module and loader, this is known as a load time. And in memory binary memory image, this execution, this is mainly by execution time. And a general diagram for multi step processing of a user program is shown. And that's all from my side. The memory management of general purpose operating system is already seen. I think it's clear. And that's all. Thank you.